Welcome to my pre-algebra class. We're on chapter 10, section 9, and we're going to be working with indirect measurement to find a missing side of a triangle. We use indirect measurement when we're trying to measure triangular shapes that physically we cannot do. So for example, if I wanted to measure the height of this tree, if I used the height of a person and its shadow that that person casts, I can figure out the height of the tree by using similar triangles and the shadow of the tree. So here I have the height of this boy, which I can measure, and it's 5. His height is 5, and we want to find the height of the tree, which is x. And I have his shadow, which is 3, and I have the tree shadow, which is 15, which I can physically measure on the ground. Then I do cross products. I get 75 equals 3x. Divide by 3, and I get 25 feet is the height of that tree. So here we indirectly got the measurement of the height of the tree by using a similar triangle. So this is the way we're going to be solving our problem. So you need to turn to page 473, and we're doing exercises 1 to 18. Problem number 2. We're trying to find the height of a lamppost, and we're using a person that's 5 foot 10 inches tall and casts a shadow of 5 feet. So we have 5 feet, 10 inches to h. The height of the lamppost is the same as 5 to 12. 10 inches is 5 2/3 feet. And that'd be 10 inches over 12 inches. So that'd be 5, 6. Over h equals 5 over 12. So using cross products, 5 and 5/6 is 35/6 times 12 equals 5h. We can cancel the 6 with the 12, and we get 70 equals 5h. Then divide by 5, and 5 goes into 70 14 times. So the height of that lamppost is 14 feet. Be sure you do not use repeating decimals. Remember, 5/6 is 0.83 repeating, so we couldn't use that decimal. Number 4. We want to find the height of the house, and we're using a mailbox and its shadow to figure out the height of the house. So the mailbox 1.8 meters high, and we want to find the height of the house. The 1.8 meter mailbox casts a shadow that's 3 meters long, whereas the house casts one that's 10 meters long. Cross products, 10 times 1.8 is 18, and 3 times h. Divide by 3, and we find that the height of the house is 6 meters. Problem number 6. A man who is 1.6 meters tall casts a shadow that's 50 centimeters long. At the same time, a nearby television tower, it's a weird tower. Anyway, our tower casts a shadow that's 8 meters long. And we want to know how tall the tower is. Well, we have to make sure they're all the same unit. 50 centimeters, we'd have to move the decimal point 2 places to the left. So it's 0.5 meters. So everything's in terms of meters now. So the person's 1.6 meters tall, and the tower is h meters tall. The shadow it casts, the little guy, is 0.5 meters, and the shadow cast by the tower is 8. Cross products, 1.6 times 8 equals 12.8. And that equals 0.5 h. Divide both sides by 0.5, and we get 25.6. So 25.6 meters is the height of the tower. Number 7 through 11, you have the figure at the right illustrates a method of indirect measurement that is used by surveyors. In this case, the unknown distance is the distance across chosen lake, represented by the length of line segment AB. The surveyors create similar triangles by marking off DE parallel to AB. Okay, with that in mind, number 8, which two angles are equal in measure as a result of the fact that line segment DE is parallel to AB? Well, this is what we have here. We have the length across the lake. We've dropped a perpendicular down here. And we have this length. And this. And we have, this is AB, C, this is D, E. And this is 28 feet, and this is 63 feet, and this is 32. And question number 8 asks which two angles are equal in measure as a result of the fact that DE is parallel to AB. Well, angle ACB our vertical angles, they're equal, but we're worried about the parallel lines. So they got this transversal here. So these are alternate interior angles. So angle A and angle E are congruent. And it's because they're alternate interior angles. So we actually end up with two similar triangles because these two angles are equal and these are right angles here. So all the angles are equal, congruent, therefore it's going to be, these are going to be two similar triangles, and we can use proportions to solve this. Number 10, write a proportion involving corresponding sides of the triangle. Define the length across the lake, D. So D and D is to 32 as 63 BC is to CE, which doesn't help us too much. No. 63 is to 28. Because this side's across from here and this side's across from that one, so they're corresponding. And then problem number 12. The figure below shows how surveyors laid out similar triangles along the banks of the Sage River. Using these triangles, calculate the distance across the river. Well, we have the same setup as the one before there. And they have this is 35, this is 120. We don't know this. We know this is D. Excuse me, we do know this. This is 180. So we want this distance right here. We don't know that. So we can set up a proportion. D is to 35, as 180 is to 120. And drop the end zeros, and we get 12D equals 35 times 18, which is 630. Divide both sides by 12. And we get 52.5 meters. And that's the distance across the river. Problem number 14. In the figure on the right, the triangles are similar. Find H. So we have 6 feet, 6 inches for the height of the person, which is 6.5 feet. 6 inches is half a foot, so we can use the decimal point 5 as terminating. Over the shadow the person casts, which is 6 feet. We want the height of the, I guess that's a door, or the building rather, and its shadow is a distance of 12 feet. Cross products gives us 6.5 times 12, which is 78, and 78 divided by 6 is 13. So 13 equals the height of that building. And 16, solve by drawing a diagram. Sarah hiked 4 miles south, 2 miles east, 8 miles north, and 2 miles west. Where was she in relation to her starting point? So this is the starting point, and this is her ending point. She's 4 miles north. And there is no 18. So we stop at 16, we're done. That concludes the evens. Be sure and check the back of the book for the odd answer.